All right. Hi, everybody. This is Erden, and I'm having a particularly bad hair day, so there will be no visual of me today, just my voice over these slides. So I just want to make a really quick little video tutorial about some key concepts from the first week of the class. These are concepts that are found in one or both of the books, the Morling book and the stats book by me. So let's talk about a few ideas. Research designs is talked about, I think in both books, but more in mine. Experimental research has a defining characteristic that at least one variable, the independent variable, is manipulated. So if there's no manipulation of the independent variable, it's not an experimental study. And by manipulation of the independent variable, we mean that the researcher does something to manipulate this variable. For example, say that I'm doing a study about the effectiveness of different kinds of pain medication, and I want to test Tylenol, Advil, and a placebo. If I give some members of my sample Tylenol and other members are assigned to the Advil group and other members are assigned to the placebo group, I'm manipulating that variable so that some people are in different levels of that independent variable. So that's what makes a study an experimental study. And I'm trying to use this to see if the different type of drug causes changes in pain relief. So experiments are good for testing causal claims. Quasi-experimental is also when you are manipulating something, so the experimental part is still there. But you're not assigning people to different groups. You're using existing groups that were pre-existing and then maybe treating them differently. So for example, you see this a lot in education research, where a researcher wants to see if doing something different, say in math, increases learning. So rather than assigning kids to different classrooms, they'll take existing different classrooms and they'll say, okay, this existing classroom gets this math lesson and this other classroom gets a different kind of math lesson, and then I'm going to see which group does better on my test. So randomized controlled trials is a very sort of popular current research method that is quasi-experimental. Correlational is when you're looking for relationships between two variables, but you're not manipulating anything. So I just want to know whether the time of day that people wakes up affects their mood. I'm not manipulating the time of day that they wake up, and I'm not manipulating their mood. I'm just measuring those two variables and seeing if they're related to each other. Survey research is often correlational. Then qualitative research is when the researcher is not necessarily measuring a variable, but they're collecting data in a qualitative way. They're observing, they're interviewing people, things like that. And then there's a lot of research that is mixed methods. I do a lot of mixed methods research where I'll collect surveys and then do statistical analysis on it, but then I'll do follow-up interviews with people that I surveyed. So mixing in some qualitative mixed methods are not uncommon. It's important to understand sampling methods and to be very clear with how you use these terms. Random samples. Random doesn't mean haphazard or like we just got whoever we got in our sample. Random means that you are very systematic to make sure every member of the population has an equal chance of being selected in the sample. So keep in mind that when you collect data from a sample, that sample is supposed to represent a larger population. So if I want to sample of 10th graders and I give surveys to 100 10th graders at my kids' high school, I got to be careful and talk about who is my population. Is my population all 10th graders in the world, 10th graders in the US, 10th graders in California, 10th graders at that one particular school? So if it's all 10th graders in that particular school, a random selection means I've got to randomly select 100, just pulling names out of a hat, and that's my sample. But everybody in the population has to have an equal chance of being selected. Random sampling is great in that your sample generally represents your population, but it's hard to get a random sample. Representative is where you purposely select members of the population so that they represent your population on important characteristics. So it's pretty common, for example, if I want to do a study in the U.S. and I want to make sure that my sample represents my population in terms of gender and race. If 13% of the population in the U.S. is African American, I'm going to select my sample in a way that 13% of my sample is also African American. So this helps us generalize the results from our sample to the population. And by generalize, I mean whatever we find in the sample tells us about what's really going on in the population. But this is also can be pretty tough to do, and it's hard to select on every variable that might be important. So if I select my sample based on race and gender, I might miss socioeconomic status, and that might have an important effect. Convenience is where you just kind of go and get your sample in an easy way. So I want to do a study on 10th graders. I'm going to go to the high school right down the street from where I live because it's easy to get to, and that's a convenient sample. 10th graders in Berkeley might be different from 10th graders in Ohio, so maybe my results won't generalize if I use a convenient sample, but the benefit of it is it's easy. Types of variables. We talk about types of variables in a lot of different ways. One is how the variable is measured, or sort of what scale it uses. Categorical is also known as nominal, and that is measured with discrete categories. So male and female is a categorical variable. Black, white, Hispanic, Asian American, categorical variables. Ordinal variables are variables where the order of the variable matters, and but the distance between each number on the scale might not be equal. The classic example is something like, I want to measure the richest people in the Bay Area. Well, the richest person is going to be richer than the second richest person, and that second richest person will be richer than the third richest person. So there's an order there. But the distance or the difference in wealth between the first and second richest person might be different than the difference in wealth between the second and third person. So that's what I mean by the distance might be different between the intervals. And then interval ratio means that you are using numbers and the distance between each number is equal. So your height measured in inches is an interval ratio variable, because the distance between each inch is the same distance. We also talk about variables by their function. So there's predictor variables. I want to see if I can predict your happiness based on your income. So income would be the predictor variable. Happiness would be, the outcome variable. Independent variable is a variable that we're thinking the dependent variable depends on. I wonder whether, your happiness depends on your income. The independent variable there is your income, and the dependent variable there is your happiness. So if you use the words independent and dependent, you can think about what they mean, and that'll help you remember which variable is which. I wonder if your height depends on your age. Age is the independent variable, height is the dependent variable. And then there's also variables like that are not in your study that might affect your results. An extraneous variable. I wonder if your height depends on your age. We talked about height being the dependent variable, age being the independent variable. But your diet affects your height too. And if I don't include your diet in my study, that's an extraneous variable because it wasn't included in the study, but it might affect the results. And another term to keep in mind is operational definition. So we have a variable in mind, a conceptual variable, but then we have to measure that variable, and that's the operational definition. If height is my conceptual variable, The operational definition of height is how I measure it. Am I measuring it with a tape measure? Am I measuring it with some sort of laser measure? Am I measuring in inches? Am I measuring it in centimeters? So the operational definition is how you actually measure the variable that you're talking about. Excuse me. Let's talk about types of validity. This is in chapter 3 of Morling. First of all, just validity in general means how trustworthy are the results of your study? What are things that might affect whether your study is believable? So construct validity is also more commonly known as face validity, and it just means are your measures in your study really measuring the things that you say they measure? If my study is about happiness and I ask people, how happy are you? There's questions about whether that's a good, valid measure of happiness, right? Because how happy are you is like, you mean right now? You mean in general? You mean at the moment? You mean with my appearance? You mean with my relationships? What do you mean by happiness? So just asking people, how happy are you, might not have face validity. It might be more complicated than that. External validity is also known as generalizability or ecological validity. How well do the results of your study apply to other groups and other situations? I talked about if I want to understand how 10th graders think about what 10th graders think about drugs, and I only include 10th graders from Berkeley, is that going to generalize to 10th graders who aren't in Berkeley? If I want to know whether people perform better when they're being yelled at, or no, that's a terrible example. If I want to know whether students perform better when they are given encouraging words, and I study this in my lab where I bring a 10th grader or a student in one at a time and I tell them, you got this, good job, and I find that they do better, is that really going to tell me like what would really happen in the classroom if I give encouraging words? If I say good job to a whole class of students, is that going to have the same motivating effect than the one student I told good job when they were sitting in front of me in my lab? That's ecological validity. Are the conditions of your study going to translate to other conditions that are more genuine in the real world? Statistical validity means were your results significant? Was there much of an effect? How big was the effect that you found? Was it statistically probable? That kind of thing. We'll get much more into that. Internal validity refers to cause and effect. If I say one thing causes another, how confident am I in that? Are there other things that might have caused that? Does smoking cause cancer? Well, probably, but have we ruled out other things that smokers do that might cause cancer, like eating a lot of red meat or not exercising? So that's what internal validity is. And then criterion validity is a little bit trickier. There's two parts. There's concurrent validity, meaning if your measure of something is really valid, it should correlate with other measures of the same or similar things. If I decide I'm going to measure your height with a laser measuring tool, the height that I find with my laser measuring tool better be really similar to the height that I find with a tape measure. If it's not, then one of my measures is not valid. And then there's predictive validity. So if my test really measures how well you're going to do in college, it better predict your college grades, right? So the SAT is supposed to be a predictor of how well you do in college. Does it do that very well? Not particularly. It does it a little bit, but not all that great. So those are the two parts of criterion validity. Statistical significance. We will save that for now. So I think that's it for now. And we'll get into statistical significance later. So just a little mini lecture on some key concepts.